Hello everyone, good evening. Here we shall solve some KCET previous year questions of chapter Semiconductor Electronics, Materials, Devices and Simple Circuits. So any doubts if you have in any solution, then write that in the comments. We shall obviously clarify them in the different videos. And any other chapter of physics more difficulty, please mention the name of that chapter in the comments. Then we shall give more clarity on it, solve questions. Also, some important homework questions will be uploaded. Sapience Education application. So please install our Sapience Education. It has been provided in the description. So in the first question, this asks that in unbiased PN junction, the potential is at P is equal to that at N, and potential at P is positive and that at N. Potential at P is more than that at N. Of the options. So the potential at P is less than that at unbiased. Option D is the correct answer. Then number 2 is told to get an output y is equal to 1 from the circuit shown. The inputs A, B and C must be reciprocal. So here we have A or B, and with that output we have AND with A or B and C. It is 1. So if you take 1 or 0, that is 1 and 1, that so 1 0 and 1 I can take, and 1 or 1, that is 1 and 0 is 0. That means that C should be 1 and A is the correct answer. That's why here we have this one is called as the OR gate. This is the OR gate and this is the AND gate. Common emitter amplifier, the input signal is applied across common emitter amplifier, the input signal applied across we have base, emitter and collector. So in the common emitter, where the input signal is applied across base emitter. Option D is the correct answer. Question number 4 is in the following combinations of logic gates, the outputs of A, B and C are reciprocal. So in the output of A, that will be 1 and 1, 1 and 1, 1 and 1, 1, and it's not 0, 0, not of 0, not of 0, that is 1. Actually what happens here, the output 1 and 1, that is 1, and not of that, that is 0 here, and not of 0, that is 1, no, and 0, 0, and this is OR gate, so 1 or 0, that is here, this is 0, so not of 0, that is 1, not of 1, that is 0, 1 0 is 1, no 0, and not of 0, that is 1. and here this 1 is 1, 1 or 1 that is 1, not of 1 that is 0, and 1 and 2 that is 0. So answer is the answer is 1, 1 and 0. So these are the outputs of A, B, and option C is the correct answer. The forbidden energy gap of germanium is 0.72 electron volt. It is called as the energy band gap. 0.72 electron volt. Given AC is 12,400 electron volt into Armstrong, the maximum wavelength of radiation that will generate electron volt pair is. So we have to equate this energy band gap with the energy of the radiation that will generate electron hole pair, hc by lambda. So the maximum wavelength that will generate electron hole pair, that will be hc by energy band gap, that is 12,400 electron volt divided by 0.72 electron volt. That will be equal to electron volt will cancel, so 12400 divided by 0.72 Armstrong. So this will be equal to 1722 Armstrong. So option C is the correct answer. Then question number 6, it is told pick out the statement which is not correct. At a low temperature, the resistance of a semiconductor is high. So as temperature increases, the resistance of semiconductor decreases. Movement of holes is restricted to the valence band only. Width of the depletion region increases as the forward bias voltage increases. In case of an NP junction diode, forward bias condition, the diode heavily conducts. So the width of the depletion region will decrease as the forward bias voltage increases. Option C is the wrong statement. Then in question number 7, it's told identify the logic operation performed by the circuit given here. So here this one is suppose A, this input is suppose A, this is B, so A, B, A or B whole not. So we know that A or B whole not, it is equal to A naught and B naught, where we are applying the De Morgan's law. This is A or B whole not B naught. So if this is equal to C, suppose C or C whole not, C or C whole, C naught and C naught, so that is equal to C naught. You have to find, so the output is C naught actually, so this is A or B whole not and its whole not again, that is A or B. So it is, so this whole logic operation is nothing but the OR gate. So option A is the correct answer. Then question number 8 is told an PN transistor can be considered to be equivalent of two diodes connected. Which of the following figures is the correct one? So the NPN, so emitter, base, collector. The emitter, base, and the collector. So the emitter should be n type, base should be p type, and collector should be n type. So it should be like this. So option B is the correct answer. Question number 9, it is told, in the case of forward biasing of PN junctions, which one of the following figures correctly depicts the direction of conventional current indicated by an arrow mark? In the case of forward biasing of a PN junction diode, forward biasing PN junction, which one of the following figures correctly depicts the direction of the conventional current? So forward bias means PN junction. P should be P type. P side should be connected to the positive terminal of the cell. N type should be connected to the negative terminal, and the current should flow from P to N. It means that option D is the correct answer. Question number 10, it is told the output of the given logic circuit is. So here, so this is A, this is B, so this is A or B, this is A, this will be A or C, and here, so this will be A or B and A or C. Y will be equal to A or B, since this one is AND gate, A or B and A or C. This will be equal to A and A plus A and C plus B and A plus B and C. So A and A, that will be A. So this will be A plus B and A plus A. So option C is the correct answer. And question number 11, so for a transistor, beta equals to 100, so the value of alpha is how? So we know that the value of beta is equal to alpha by 1 minus alpha. The beta equal to alpha by 1 minus alpha. So beta minus beta alpha, that is equal to alpha. Say alpha into 1 plus beta, that is equal to beta. So alpha can be said it is beta by 1 plus beta also. So this will be 100 by 101. So it is approximately 0. Slightly less than 1. Option B is the correct answer. Then in question number 12, it states, say the following truth level with A and B as inputs for which gate. So one inputs 1 and 0 are there, and the output is 1, 1, 0. It means that if so it is called the, and it is actually OR gate only, but one that is coming, so it is exclusive OR gate. That is the XOR gate. So option C is the correct answer. Since for XOR gate, the 1 XOR 0, 1 XOR 0, that is 1, 0 XOR 1, that is 1, but 0 XOR 0 and 1 XOR 1, that is also 0. Then question number 13, it is told in which of the following statements the obtained impure semiconductor is of p type. Germanium is doped with bismuth. So p type means that When if silicon or germanium is doped with a trivalent atom, it is doped with a trivalent atom. Trivalent atom. So trivalent means it should be in the group number 13 periodic table. Should be boron, aluminum, gallium, indium, gallium. So when germanium is doped with gallium, then it will be of a p-type impure semiconductor. So option C is the correct answer. And when silicon or germanium is doped with a pentavalent atom, it means any element in the nitrogen family, means in the 15th group, then we will obtain an n-type impure semiconductor. In question number 14, it is told that the width of the depletion region in a PN junction diode is increased by forward bias, increased by reverse bias, decreased by reverse bias. Width of a depletion region in a PN junction diode is width of the depletion region width of the depletion region width of the depletion region at PN junction is increased by reverse bias. So option A is the correct answer. Question number 15, it is told when the transistor is used as an amplifier, then emitter base junction should be reverse bias. Okay, so which one should be reverse bias and which one should be forward bias? That we have to think. So when the transistor is acting as an amplifier, then the emitter base junction should be forward biased. Emitter base collector. So the emitter base should be forward bias and collector base should be reverse bias. And D is the correct answer. In question number 16, it is told the output of an OR gate is connected to both the inputs of a NAND gate. Output of an OR gate. Output of an OR gate is connected to both the inputs of a NAND gate is like, so the combination will serve as, so here if the inputs are A or B, so this is A or B is equal to C, suppose, so this will be C and C whole naught, C and C whole naught, this will be equal to so C and C, that is C, so this is C naught, this is A or B whole naught, so it will act as a NOR gate. Option D is the correct answer. Question number 17 is told in n-type semiconductor, electrons are majority charge carriers, but it does not show any negative charge. The reason is In n-type semiconductors, electrons are majority charge carriers. In n-type semiconductor, electrons are majority charge carriers, but it does not show any negative charge. The reason is electrons neutralize with holes. Yeah, so the electrons are majority charge carriers, but since why? Atom as a whole is electrically neutral. C is the correct answer. Question number 18, it is told, for the given digital circuit, write the truth table and identify the logic gate it represents. So we have to find which logic gate it will represent. So this will be A or A or not. A or A means A only. So this is A not. And this is also B or B or not. Since this is NOR gate, B or B is B. A or A is A, B or B is B. So this is B not. So this is again a NOR gate. So this is A not or B not. Not or B not and whole not. So this will be equal to A not. So this is A double not and B double not. This is A and B. So simply it is acting like an AND gate. Option C is the correct answer. Here it is told, if alpha current gain of a transistor is 0.98, then what is the value of the beta current gain of the transistor? So we know that beta is equal to alpha by 1 minus alpha. This will be 0.98 by 1 minus 0.9. This is 0.98 by 0.02. This is 28 by 2, which is 49. And D is the correct. Question number 20, it is told, the circuit has two oppositely connected ideal diodes in parallel. What is the current flowing in the circuit? Ideal diodes are connected in parallel. It means that here current will flow. It means that in this region current will flow, but in this region it is reverse. This diode D1 is forward biased, so through diode D1 current will flow, but diode D2 is reverse biased, so through diode D2 current will not flow. Through diode D2 current will not flow since it is reverse biased. Diode D1 is forward biased, so through this only current will flow. So it means that through 2 ohm resistor there is no current flowing. I1 equals to 0. So this only current will flow, which I can call it as I. I that will be equal to 12 by 4 plus 3, 7. 7 1 is 7. 5 was 7, so that's 1.77 is 49. So 1.71 ampere. So option C is the correct answer. Then in question number 21, it is told an LED is constructed from a PN junction based on a certain semiconducting material. Based on a certain semiconducting material whose energy gap is 1.9 electron volt. What is the wavelength of the emitted? The wavelength of the emitted light is. So we have to find the wavelength of the emitted light. So you know that hc by lambda that should be equal to the energy band gap. So the wavelength will be equal to hc by eg. hc we know that it is equal to 1242 nanometer electron volt. So lambda will be equal to 1242 divided by 1.9 nanometer. This will be equal to, so approximately I can say 2 6 12. We can take 1.9 as approximately 2. So 2 6 are 12, 2 to the 4, 2 1 2, 621 nanometer approx. So which will be equal to 621 into 10 power minus 9 meter, or approximately 6.21 into 10 power minus 7. So option D is the closest one. Question number 22, it is told the given truth table is for which gate? For 0 0 it is 1. This will be the AND gate. We have 1 and 1 is 1, remaining are 0. So it is the NOT of that. So it is the NAND gate. This NAND gate. So option D is the correct answer. Since why this output is the NOT of the AND gate, it is simply the opposite of AND gate. Yes, so here question number 23, it is told the input characteristics of a transistor in CE mode is the graph obtained by plotting input characteristics transistor in CE mode. The graph obtained by plotting IB against BE, IB against BE at constant DC. So option C is the correct answer. Constant DC voltage is required from a variable AC voltage. Which of the following is correct order of the operation? Constant DC voltage is required. Constant DC voltage is required from variable AC voltage. In variable AC voltage, a constant DC voltage is required. So which of the following order of the first one? We need a rectifier. First thing that we need is a rectifier, and then we need a filter, and then we need a regulator. So option C is the correct. This is why the AC voltage will converted into the DC voltage by the rectifier, but we need a filter and then a regulator to adjust the peak voltage. Question number 25, it is told in a transistor the collector current varies by which is delta IC, that is equal to 0.49 milliampere. Emitter current varies by is IE, is equal to 0.50 amp. The current gain beta measured is beta is equal to, so beta equals to is delta IC delta IB. Now know that delta IC We know that IC plus IB, IC plus IB, that is equal to I. So collector current plus base current is equal to emitter current. So therefore I can say delta IC plus delta IB be equal to delta I. Therefore delta IB, that will be equal to delta IE minus delta IC. That will be 0.50 minus 0.49 milliampere, 0.01 milliampere. So this will be equal to 0.49 milliampere divided by 0.01 milliampere. So this will be equal to 49 by 1, which is 49. 49 is the current gain with beta. So option A is the correct answer. Question number 26 is told. Number 26 is told that identify the logic operation carried out by the following circuit. So here A, this is A, the input. So both the inputs for the NAND gate is A. This is A and A and A, which is A. This is also B and B. So B and B is B. Not of that, that is B naught. Here also again. So Y is equal to A naught and B naught. Whole naught of that. Therefore, Y is equal to A naught and B naught whole naught. So if we apply the De Morgan's law, it will be A or B. So this is A double naught or B double naught. So here we are applying the De Morgan's law. It will be equal to A or B. So why this logic operation is similar to an OR gate. Option D is the correct one. Question number 27. Told in the figure shown, if the diode forward voltage drop 0.2 volts, the voltage difference in between A and B is. In the figure shown, if the diode forward voltage drop 0.2 volts, 5 kilo ohm, so 5 kilo ohm, this is 0.2 ampere current. This one is the volts. Voltage difference in between A and B is So the voltage difference in between A and B, that will be so simply there is V is equal to IR. So I current is 0.2 milliampere, means 10 power minus 3, so 5 kilo ohm, so 5 into 10 power 3. So this will be 5 to 10, so 5 kilo ohm, this is also 5 kilo ohm. So here the diode forward voltage drop, that is 0.2. So it means that this is VA minus IR. R is this, then minus 0.2 minus IR, that is equal to VB. The voltage difference between V and VB, that is 0.2 plus I into 2R. So this is 0.2 volt plus I 0.2 into 10 power 3 to 2R, that's the 10 kilo ohms, so 10 into 10 power 3. This will be 2.2 volts. So option B is the correct answer. Question number 28 is told that which of the following it gets considered as universal. So the NAND gate and NOR gates are considered as universal logic gates. So here in the option B we have NAND gate. So option B is the question number 29. It is which of the following semiconducting devices is used as a voltage regulator? Zener, diode, laser, diode, photodiode, solar. So the Zener diode is used as a voltage. Option A is the question number 30. Question number 30, it is told the three parts of a transistor. Emitter is of the emitter is of moderately sized and heavily doped. Emitter is moderate sized and heavily doped. Option A is the. And in question number 31, it is told the energy gap in case of which of the following is less than 3 electron volt. The energy gap in case of energy gap in iron copper. So here so the energy gap in case of which of the following is less than 3 electron volt, that is germanium. Option C is the correct answer. Question number 32 is told in a CE amplifier the input AC signal is to be amplified is applied across forward biased emitter base junction. A is the correct answer. Since why in CE amplifier this is base emitter collector, the output voltage is applied, the output signal is across the collector and the emitter, which is reverse. Collector and the emitter, which is reverse biased, and the base emitter is forward biased, where the input signal is being applied. Question number 33, it is told if A is equal to 1 and B is equal to 0, then in terms of Boolean algebra, A or B naught, that is equal to how much? 1 or 0, naught of 0 is 1. So 1 or 1, that is 1. 1 means it is. So question number 33 is the option. So I can say it A also or B naught also. So B and C both are correct options. Question number 34 is told that the density of an electron hole pair in a pure germanium is the 3 into 10 power 16 per meter cube at room temperature. On doping it with aluminum, it is a p-type atom. The hole density increases to 4.5 into 10 power 22 per meter cube. Now the electron density in the doped germanium. Now we know that Ne into Nh, that is equal to Ni square. And when in an intrinsic semiconductor, Ni, so it means the number of the electron density, which is Ne, will be Ni square by Nh. So that will be Ni is this, the intrinsic carrier concentration, is N 3 into 10 power 6 whole 16 power 16 whole square divided by Nh, that is 4.5 into 10 power 22. That will be 9 into 10 power 32 divided by 4.5 into 10 power 22. 4.5 into 2, that is 9. So 2 into 10 power 10 per meter cube. So option B is the correct answer. So here we shall end the first part of this chapter on semiconductor electronics. So in the second part we shall solve from question number 35 onwards. So hope all of you have understood the solutions of these 34 questions, this first part. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them. Some important homework questions will be uploaded in the Sapience education application, which will be based on the previous year KCET exam. So please install our Sapience education application, which will be helpful for your exam. So thank you everyone.